of the day and actually of Atlas Camp in this track. So I'm happy to introduce Ian to you. His favorite story is the Phoenix Project. Who knows about this one? Some people. It's basically a novel, but about IT, DevOps, and helping your business succeed. So it's a great and actually pretty funny read, so I would definitely recommend it. But today, Ian isn't going to talk about DevOps. He's actually going to take us on a journey into the darkest corners of Git. I hope you'll enjoy it. Please join me in welcoming Ian to the stage.
Great. Okay, thanks all. So actually, these days, I'm in a role where I end up talking to maybe the top 5% of Atlassian customers. We get into some pretty hairy discussions sometimes about very large Git repositories. But that's just today. 4 years ago was when I was joining Atlassian, and my knowledge of Git was somewhere on the left here. So give you a chance to kind of catch up there. Yeah, so my depth of experience was pretty much, okay, I kind of use this like Subversion. I know how to get files in there, and sometimes it just doesn't work how I expect it to, so I'll just drop the connection to the central Git repository, clone a new one, and bring the changes that I mean in, and that was the extent of knowledge that I had. But 2 months into my job at Atlassian here, in those first months, I was out on the road giving a talk very much like this, and it really helped me to understand Git a lot more. So these are just some of the lessons that I've learned along the way, and hopefully after you hear a little bit more about this, you'll have a lot more confidence with Git as well. So I usually try to cover some of this in about 10 minutes, but we'll take it a little bit slower today. We've got plenty of time. We're going to start by looking at some of the Git internals. I found by just knowing a little bit more about how Git thinks about the world that I was better able to use Git more effectively. All right, let's start with an interesting statement from the Pro Git book. Does anyone know this Pro Git book? All right, so basically everyone should know this book because it's free and really covers all that anyone really needs to know about Git. What it says about the definition of Git is that it is fundamentally a content addressable file system with a VCS user interface written on top of it. Okay, so for whom does that clarify what Git is? Oh, all right. Okay, so what we're going to do is unpack this statement a bit, try to understand what this is talking about so that we can understand Git's worldview. All right, so let's do that by starting a new repository. So I've got some commands here that you might go through. We're going to go into a new directory. Okay, we do a directory listing and we find nothing's there, new directory. We'll do a git init, and then we get this new .git directory. And then that's where we start with our Git operations. Okay, so if we look inside of that Git directory, here's what we find. Has anybody done this before? Looked inside the .git directory? Really? Yeah, a few hands. That's good. A few things in there that you might find useful are this config file. That's repository level options that you can use. Most of the time when you set up Git, you'll do something to tell it what your email address is and what your name is. Those go into a global Git configuration in your user directory. But you can override all of those options, which are things like which editor to use, which diff tool to use, merge options, all kinds of things. You can all override at the local Git repository level. That's very useful because one of the things that I think you may want to do is override where this hooks directory is. That would allow you to actually check in Git hooks, so you can pull them up a level in Git and therefore share them with more people. So the hooks the hooks directory here contains a set of files, some custom scripts that will be fired when certain Git actions occur, like after a commit. Are there any folks here using Git hooks right now? Yeah, okay, good. A few hands. It's kind of a rare thing for people to get into, but it can be very useful for doing things like making sure that certain things have been done before every commit. Maybe code formatting, maybe linting, maybe even making sure that the git commit message has a Jira issue number in it, for example. Okay, so those are some of the things that are in that git directory. But where I want to focus attention for the rest of this is in this objects directory, because that's where the interesting things are happening. So when we have our brand new Git repository, we get a blank info directory and a blank pack directory. Let's start looking at what those things are. So let's add a new file and see what changes. So we do git add some file.txt. There's not any content in the file yet. But we still get a SHA that will show up inside of that objects directory. That SHA, or that file, is now a zlib compressed file. So it's already starting to do some efficiency there by doing the zlib compression. And the SHA is an identifier. The SHA is identifying that particular content, and its history starts to track its history inside of Git. Okay, so we talked SHA, zlib, and it's also the notion of a blob. So basically, from the Git perspective, we just pull all this content together into one. This is starting to get into the content addressable part. So the blob is just the content that is in that file. Then we need to commit a change. So git commit -m, some message, our first commit. And what do we see here? Okay, so the Git objects are starting to fill out. We already have the blob that we had added, but now we have a couple other things. One of them is a tree object, and another is the commit itself. So let's see how these are related. There's a graph that will kind of help us understand this. We have all of these blobs. These are individual bits of content that are now all addressable by a SHA-1. We also have the tree object. Now, the tree object is effectively a mapping between the file name and that SHA-1 that we have. So this kind of keeps together all of the location information that's really important when we need that snapshot on disk. And then the commit is what really kind of defines Git as a version control system. So it's got a parent, which is a reference to something that happened before. So this is what makes Git a directed acyclic graph. Maybe that's another phrase that also needs some unpacking. But basically, there's a pointer to the history that this commit has. Now, that could be multiple parents in the case of when you merge together. It is also the place that is remembering the author, the committer, and then has a reference to this tree for all of the rest of the content information. Okay, so this is the directed acyclic graph. The idea there is that over time, all of these commits are chained together in what we often see in these sequence diagrams that show us the branches and the relationship of commits. All right, so let's take this a little bit further. Let's stage some additional changes. So now we'll put some content into our blank text file. We'll add it, and let's see what changes there. Okay, so now we have an entirely new blob. All right, so we're looking at the original history. We can always get back to that. Plus, we have the current content of the whole file, now stored as a blob. Now, if we kind of think about it, wait, if we just keep doing this over and over again, and Git is going to track all of these objects, well, isn't this just going to explode on disk? And I think we all know from our day-to-day life, well, Git doesn't really do that. So something else is going on here. Okay, so the trick is that Git has its own form of garbage collection. Usually, this will kick in without having to issue an explicit command. It is addressable. You can do git gc at any point in time, but most of the time, this is going to kick in when you do a pull or a push, or on certain cycles, a certain number of commits are already happening. And even under the covers for garbage collection is something known as pack objects. And what that does is take all of those loose objects that were in the directory and pull that into pack files. So again, basically what we're doing is we have all of these loose objects, those blobs, the trees, the commits, and it takes all of that information, creates a pack file out of it that is delta encoded and zlib compressed. All right, so why does all of this internals matter? What is this all about? What is this telling us? Well, one thing is that it makes Git operations really extremely fast. And I think we know that from day-to-day operations. If you have used Subversion, a lot of those operations that used to make a network call are now just local. But even the network calls, because of the zlib compression and delta encoding, are sending back and forth just changes. So that makes Git particularly effective at maximizing network traffic. The one operation we kind of have to watch out for that kind of can come back to bite us is that when we do a clone, we're getting all of the history that Git knows about. So that's not just left on the server somewhere. And that's an operation that we often do in our CI cycles so that we can get a very clean build. Or if you're using tools like Bitbucket pipelines, it's because the environment that we're cloning into is always fresh. So we must do a clone operation. So that's one thing to watch out for. Git clones are quite expensive in this scenario, but then everything else is sped up by this internal structuring. All right, and then that also goes to efficient. So because the Git object database is compact on disk, it's also good for network operations. Okay, so another thing that's kind of interesting about this internal mechanism is that it means that Git is safe in a certain way that sometimes the centralized version control systems can't really replicate. All Git operations are atomic. If it can't do the checkout, like there's a file lock based on some running application, then Git will just refuse to do the operation. It won't leave you in some half unfinished state. And that also makes it fairly resilient, that there is a local copy of history on disk, means there's a built-in rollback capability, so you can always get back to what you had before. That's even true in cases of things that seem to be doing very almost destructive operations. So Git rebase, for example, is something that rewrites history. But I have had situations where I'm trying to rebase from one branch to another, I do it wrong. You can unwind that using the Git ref log, which is an internal sequencing of all of the changes that have been made. So even these seemingly destructive changes can be rolled back. And then it's distributed. So even if Bitbucket should go down or is lost forever somehow, you still have every developer having a copy. Maybe slightly incomplete, but at least there's some distribution of that information. It's a lot less subject to loss. Now, I think that makes Git particularly interesting in an operations world where folks are often used to using FTP or SFTP to get information from one place to another. But because of these elements like safety and resilience, I would often recommend that people start looking at using Git as a way to get a set of files onto onto production systems, unless you're already using some system like Ansible, Chef, or Puppet that does full-scale configuration management. So there's another side of this that is that this internal structure really helps aid in autonomy. The fact that there's a local copy for everyone means, in fact, that there's not very much control there at that local level. So for some enterprises that can be a little bit scary, they kind of have come to like the kinds of controls that they get with something like a clear case or a subversion. But I think this is kind of more reflective of modern practices like Agile and DevOps, where autonomy really is meaningful. You want to hand that to developers so that they can go exploring, even to the extent of making local changes to see what might happen. But control can still be enforced centrally, and that's why the rise of tools like Bitbucket or GitHub and so on, that those central mechanisms provide the place where everything still has to come together, and therefore is an aspect of control. All right, so I'm just going to kind of pause there and then open up to see if anybody has additional questions about Git. We can take them on the fly here.
Anybody? Okay, then thank you very much, Ian.
You're welcome. Thank you.
So that's it for this track at Atlas Camp. Thank you very much for being here. Thank you very much for giving us feedback already in the app. Please keep on doing this. Please keep on rating all the sessions you've been to. Give us as much feedback as you can, both about sessions and about Atlas Camp itself. We do listen to this feedback. We use it. The fire pit room, for example, was based completely on feedback we got after the last Atlas Camp. Same with this track. This was based on feedback we got from the community. So please keep on giving us feedback. Thank you very much for being here. Have a safe trip home.